For this next example, 3, we're going to be taking a look at f of x equals negative 3 times cosine of negative 4x minus 1 plus 2. We're going to ask, what is the period of this function f of x? Now you might be thinking, wow, this is just too hard for me. There's too many numbers here that I'm looking at. Well, remember, the period only depends on b. And I'm going to show you after these examples more thoroughly why the period only depends on b. It doesn't depend on any of these other numbers in the equation. So what is the b value? Well, I've already alluded to it. It's the number that's in front of the x always. And so in this case, it's going to be negative 4. So when I write out my formula for a period, you may remember what that is. If you said absolute value of 2 pi over b, you're correct. So when I write out this formula, I'm going to be plugging in negative 4 for b. So we've got absolute value of 2 pi over negative 4, which is the absolute value of pi over negative 2, because of the 2's and the 4's divide. And that gives me positive pi over 2, because it's absolute value of negative. So the period of this function then, according to our formula for a period of absolute value of 2 pi over b, the period of this function is just pi over 2. Now, until we do the proof for this, I want to show you the graph to confirm this finding. All right, here is the graph of our function, negative 3 cosine of negative 4x minus 1 plus 2. I want you to see, let's just focus on 0. You see where this wave is? It's kind of at the bottom of the wave, not quite at the bottom at x equals 0. So if we go up and then down and then back up to that next part of the wave where it repeats, look how long it takes. It takes pi over 2 for the graph to repeat itself. So this confirms that the period of this function, regardless of all this stuff, is equal to pi over 2. I will allude a little bit to why that is. For example, this last value 2, if I change it, all it does is make the graph go up and down. It has nothing to do with the period. Okay, if I change this value right here in the parentheses, not the b, but this, what we call the c value, all it does is shift the graph to the left and right. And this is great because this alludes to an important lesson we're going to do later, which is on function transformations. And if I change the value in the front, which we're going to call a, this negative 3, okay, it stretches the graph and shrinks it, but the period stays the same. Look at what happens to the horizontal distance between the waves. It stays the same. Okay, it's the same horizontal distance regardless of what this value is in front, this a value. So this is a good visual understanding of why the period only depends on this b value. Okay, and I'll just change it right now. You can see that as the b value changes, the difference or the horizontal distance between the crest of the waves or any point on the graph changes as I change that b value. That's it for this example. If you have any other questions about it, let me know.